Hi, welcome back into Stats students. So today we're going to do one exercise on making conclusions in a t-test for a mean. All right. So let's. So let's go through a question here. All right. A local pizza store knows the mean amount of time it takes them to deliver an order is 45 minutes, right? So knows the mean amount of time it takes them to deliver an order is 45 minutes after the order is placed. The manager came up with a new system for processing delivery orders, and they were curious if it changed the mean delivery time. They took a sample of 40 delivery orders to test H naught equals to mu equals to 45. So that's your null hypothesis versus the alternative hypothesis where mu is not equals to 45 because they're curious to see if it changed, right? It could be less, it could be more, where mean is the mean delivery time under the new system. The delivery times in the sample had a mean of so this is a sample mean, right? In the sample had a mean of 48 and a standard deviation of 8. This results produced a test statistics of t is approximately 2.37 and a p-value of approximately 0.023. Assume that the conditions for inference were met. If there sufficient evidence? So in order to answer this question, you got to ask: is the p-value great more than or less than your alpha? And alpha in this case is 0.05. So we have a 0.023 is definitely less than 0.05. So if your p-value is less, right? If p-value is less, we will reject. Is there sufficient evidence to conclude that the mean delivery time has changed? So remember that H naught is that the mean is what, 40 something, 45. And then the H naught is not equals to 45. So you're saying that if your p-value is less than 0.05, your alpha, then we reject, right? We reject H naught, which means that we have sufficient evidence to conclude, right, that the mean is not equals to 45, that it has changed. So is there sufficient evidence that it has changed? Yes. Why? Because 0.023 is less than 0.05. She just works out that the first one is the answer. Okay? You always So let's check this out. Since the p-value is less than the significance level of alpha, the correct conclusion is to reject H naught, and therefore there is sufficient evidence, right? There's sufficient evidence to conclude that the mean is not equals to 45. Okay. So, jumbo eggs in Australia on average are supposed to weigh 68 grams. Tala is in charge of a quality control test that involves weighing a sample of eggs to test the null hypothesis is that mean equals to 68 grams versus where the mean is not equals to 68 grams, where mu is the mean weight of the eggs in a batch. Teller sampled 12 eggs from a batch and found a sample mean of 68.5 and a standard deviation of 1 gram. She calculated a test statistics of t approximately 1.73 and an approximate p-value of 0.111. Assume that the conditions for inference were met. Okay, so is there sufficient evidence? So here, again, the H naught is 68 grams, right? The mean is equals to 68 grams. The alternate hypothesis is that it's not equals to 68 gram. So here, the p-value or point 0 or 0.111 is greater than 0.10. Sorry, it's greater than 0.10. Okay, so this is alpha. So if doing so, we fail to reject. We fail to reject H naught, right? So we are claiming this, right? So is there sufficient evidence to conclude that the mean weight of the batch is not equals? No, right? No, because the p-value of 0.111 is greater than 0.10. So the answer is no, and it's 0.111 greater than 0.10. All right, and let's look at the. So since the p-value is greater than a significance level alpha, the correct conclusion is that we fail to reject H naught. That is not sufficient evidence to conclude that the alternate hypothesis that H naught is not equals to 68. So hopefully that help explains how to do this question. And this is the last exercise before we move on to the test. So if you have any questions, let me know. Thank you. Bye bye.